Bonjour. Je m'appelle Doug Sillars, but I am one of the speakers in English because I'm from the States, and it's been 25 years since I studied French, so I'm going to stick to English today. Today I'm going to talk a little bit about how to optimize video on the web. And I changed the title a little bit. It was Stop Stalling, but now it's Video Killed My Data Plan. A little bit about me. I'm a digital nomad in Europe. I'm traveling around with my family, but I'm originally from Seattle. I do developer relations. I help people speed up their websites, their native applications. I help people with performance, improving images, improving video. I wrote a book on how to speed up your Android app, and if you're interested, that's the PDF. I'll post the slides up later on Twitter. And if you have any questions, you want to reach out to me. I'm the only Doug Sillars on the internet, so I'm pretty easy to find. So we all know that there are a lot of people using video today, and more people are consuming video on the internet today. You know, we hear about how Netflix is a huge percentage of just internet traffic in the evening when everybody sits home and is watching TV on their computer. So we know that video is increasing, but I've talked to so many developers who aren't really sure about the best ways to put video on their website or in their native application, and so that's where this talk came from. The other thing that comes to mind when you think about video is that when you think about the size of files on the internet, video files are probably the biggest files that we ever deal with anywhere. And I had the opportunity in December to go to Russia and to speak at a conference there, and I was wondering, well, I wonder if I can use my SIM when I go to Russia. And I'm carrying a SIM from Ireland right now, and I found that if I roamed into Russia, it was 10 euros 24 cents for every megabyte. So we're going to express video size in euros, as if I'm roaming from Ireland, because, you know, you could imagine just watching a single video and my children are asking why we're only eating rice and beans for the rest of the month, right? I mean, you could spend a lot of money doing this. I turned off roaming when I went to Russia. So I went and I looked out on the web to see how people are delivering video today. Does anyone know the tool WebPageTest? So if you don't know it, it's webpagetest.org. I'll talk about it a little bit. But it is a static testing. You can test a website anywhere in the world. And there's another tool called the HTTP archive, and it uses WebPageTest to test 1 million websites every 2 weeks. And so there's all of this data about how web pages load and what the contents are in a Google BigQuery database that you can then query. So WebPageTest is this awesome tool where you enter a URL, you enter where you want the test to be anywhere in the world. They've got instances all over the world. In this case, I'm using a real Motorola G4 in Virginia. And you can change the speed, so you can test at lower speeds, which is a good thing to do when you're building a web page, because not everybody's on a really fast connection, right? If we're testing in our office, we probably have really fast Wi-Fi. But there are a lot of times we're on slow connection, so you should test to see what your web page looks like on a slower connection. And when you're done, you get results like this. You get a waterfall diagram, and the idea with the waterfall is it's every request on the web page, and you want it to be steep. You want these things to load quickly. In this case, the yellow lines are showing redirects, and for a while last year, the Webpack web page had 600 302 redirects on the web page because every single image was being redirected. And I found it just playing around with WebPageTest, and then we got it fixed. So using this data, what we find is not a lot of these web pages have video, but the use of video is increasing by about a percentile a year. So it's 4% on mobile, 5% on desktop. But when you put video on your web page, as you might imagine, speed index is an indicator of how fast the page loads. It's rendered in milliseconds. And so the speed index of the median page with video is 11 seconds, 11.5 seconds. But all other sites are about 7.5 seconds. So we've got this 4-second tax, as you might say, just for having video on your website. But what's interesting, it isn't just the video that's causing that problem. If you look at the total bytes, video only represents about 2.5 megabytes. The problem is when you have a website with video, you probably have a lot more CSS, a lot more images, a lot more JavaScript, a lot more other stuff, right? You're building a site that's pretty immersive. It's going to have a lot more content than regular websites. So as you can see here, the video website has double the CSS, 3 times the kilobytes of images, and I think double the JavaScript. And so then I was trying to figure out, where is the video coming from? Where is most on the video on the web being served from? And actually, it was surprising to me, the #1 domain for video was coming from Facebook, the Facebook CDN. Across millions and millions of web pages, it's mostly Facebook. Everything else I sort of expected. I've got Akamai, I've got Google, Cloudinary, Amazon, right? CloudFront, right? CDNs. It's coming from places where you'd expect to find video. We'll get back to why Facebook is #1 there and why it's a problem. When you're loading video on a web page, these are the metrics that people actually study to see if a video is playing smoothly. The first question is, did the video start playing? Which you'd think is not really that, it's really important, but you'd be surprised at how often it fails. So they actually have to study, did the video actually start playing? Did the video stop playing in the middle? We don't want the video to stop in the middle. And then finally, did the video look good, right? You want it to play, and then you also want people to enjoy watching it. And so if we can optimize the way that the video is sent over the network, we'll optimize all of these. So it makes sense to do what we can to optimize the video that we're serving on our websites or in our native apps. A marketing company came up with this idea of buffer rage. The idea that when a video stops stalling, people get really, really angry. And there's actually a study out there that when a website is slow, people end up throwing their phones. 4% of people admit to throwing their phones when there's a slow website. So I had to put a picture of a cracked screen up. But what's really interesting is this is actually a pretty significant problem. Conviva is one of the biggest analytics companies for video streaming. And they found that on mobile and on desktop, about 3% of all videos fail to start. They just don't start at all. And then you can see in yellow here, or it's sort of orange on this screen, 16% on mobile, people exit the video before it starts playing. And on desktop, it's up almost at 27%. So what's going on here? Why are people not seeing the video start? Let's start with this, where the video just doesn't work at all. And I think most of the time, this is due to something like this, where you click on a video and then it says, oops, we can't show the video in this country, right? Some sort of geo-fencing issue with the web page. And this isn't so bad until you realize you open up Chrome DevTools while the page is loading, and you realize it took 231 requests and 3.1 megabytes to tell you oops, right? And if you did that on mobile, I mean, if I was in Russia, that would be $30, right? There are better ways to tell your customers that the content isn't available. If you use Amazon Video, Prime Video, I have my account, it's set up in the States, but when I'm here, if I fire it up, it'll say, here are videos that you can watch when you get back to America. We can't show them in France, but here are the videos you can watch while you're here. That's a better user experience because I don't click that video thinking I can watch it and then get the oops. They've prevented me from that extra click. But let's look at these, right? Why do people, they press the button, the video should play, but people give up. So why do people give up? The clue is over here on the side. The average mobile startup time for a video is 3.5 seconds, but on desktop, it was 6 seconds. So obviously, if you're sitting there waiting, after a while, you just give up. And then if you have to wait 6 seconds for a video to start, people just, get distracted and do other things. And there's actually research for this. Akamai found that just about 100% of people will wait for 2 seconds. And after 2 seconds, you lose 6% of your users every additional second, approximately, based on this study. They found that it's different for shorter videos versus longer videos. People abandon shorter videos faster. So if you click a link for a cat dressed up like a shark, sitting on a Roomba, chasing a duck, after a few seconds, you're like, what? And you give up. But if you're going to plan to watch a movie or a TV show, right, you're already planning to sit around for an hour, an extra 3 or 4 seconds, you'll hang out and you'll wait. It's not such a big deal. So we know that if it takes a long time for a video to start up, people are going to abandon the video. When I looked back at the HTTP archive, I found that there were 36,000 sites on mobile, 55,000 sites on desktop that had video. And, you know, as you might imagine, there's a lot of overlap, right? 30,000 overlap. But what was really interesting to me was that 19% of all of the videos are identical on the desktop and on mobile. So either that means they're serving really, really small videos that are optimized for mobile, so they start up really fast on the desktop. Probably not. Or they're serving really, really, really big videos to mobile devices, which means it's going to take a long time for those videos to start up. So what are we going to do to optimize videos to make sure that they play quickly? When we talk about image optimization, there's a lot of things that we can do that are pretty well known to optimize the image. This is Josephine, my goat back in Seattle. If I take this image of Josephine, it started off at 2.5 megabytes. I can lower the quality of the image to, it still looks good. 85% is what Google recommends. Structural similarity gets you a little bit more savings. The human eye can't tell a difference. I could save it as a WebP, which is another format that's got just better compression. I can make it a responsive image. I can serve it at a size that's appropriate for a mobile device. And this is a URL using a tool called Cloudinary, where you upload the full-size file, and then you just change the parameters that are boxed there, and it creates the file for you on the fly. It's kind of a neat tool. So this is pretty well established technology. There are lots of books and blog posts, and if you're interested, I'd love to chat about this as well. But I'm here to talk about video. When I look on the web, in general, if you look at the percentile of websites, megabytes of images, you can see that in general, we serve less data on mobile than we do on desktop. This is a good thing, right? Images should be smaller on mobile than they are on desktop. What are we doing for video? Are we doing the same thing? Now, the first thing to look at when I switch this slide is look at the y-axis. The y-axis is 10 times larger, right? We're talking about video now. And it might be a little hard to see, but as we go out further, video is the gray line, or the mobile is the gray line, and we're actually serving more video to the mobile device than we are to desktops. And that's a problem too, right? We should be serving less data to mobile devices than we are to the desktop. So let's see what we can do about video and what we can do to make video files smaller. So when you start off with video, this is Nora, another one of our goats back in Seattle. Video ends up with all these files, right? And they're in order. We've got, you know, it's picture over time. We've got an audio track that runs along as the video's playing. So, but what's great about video is over the years, there's all this great compression that's built out there. And so the way video is compressed, really briefly, is that every video is broken into a group of pictures, and the iframes in green are the full image. The P frames are in the middle, they're pink here, and they're about 50% the size of an iframe. And then the B frames are 25%, and you might have 3 or 4 B frames in between all of those. And there's all sorts of really fun math that they do with vectors. And rather than talk about the math, I thought I'd show you the vectors, because that's kind of cooler. Those are the compression vectors for each P frame. These are the compression vectors on the B frames, and then when you throw it all together, you can see there's a whole lot of compression going in there over time, which is kind of cool. And that's what makes video small when when you can compress X and Y, the width and the height, and then you can compress through time, and that's why video compression is so great. However, a lot of people use animated GIFs, and we all get really excited when we have an animated GIF, right? They're everywhere, and everybody's like, yes, animated GIFs, except for the folks who built the GIF format. If you actually read the specification for the GIF format, it says that GIF is not intended as a platform for animation, even though we can do it, right? So they say don't do this, yet we are surrounded by GIFs. And so I think what's great is GIF, the medium, is awesome, but GIF, the format for animated GIFs, is not the way to go. As an example, the video of Nora the goat is 1.4 megabytes. When I turn it into a GIF, it becomes 3.8 megabytes, right? And the reason for this is that there's no compression through that time, through the time frame. And so what it is if you have a GIF at 30 frames per second, it's literally 30 GIFs being flipped through every second. And that's why GIFs are so much larger. So what people actually do is they say it's a GIF, and they just serve you a 256 color MP4 file, right? Because it's so much smaller. You can strip out the audio track because they're silent. And it's a little bit weird to hear a goat eating a leaf, too. It's a little disturbing. But you might think, all over social media, like this is Twitter, right? It says GIF in the corner, right? They're using GIFs. Why can't we use GIFs? Well, they're actually lying to you. If you actually open that up in DevTools, you can see it's an MP4, right? So even though it says GIF, it's GIF the medium, not GIF the format. And the reason for that is that this is really small. I think it's like 200 kilobytes versus like megabytes of data. Obviously for Twitter, that saves them crazy amounts of bandwidth throughput. It speeds up the app, et cetera, et cetera. And the way they do that is in HTML, you have a video tag, loop, autoplay. You have to set it to muted because on mobile, a video won't autoplay unless it's muted. And that's because Chrome engineers and Safari engineers sit in meetings too, and they sometimes browse the internet when they're not supposed to in a meeting, and it's nice to have it muted so you don't get busted. But what's actually really cool is in Safari, if you're interested in this format, you can actually put videos in the picture tag. So you could actually serve the MP4 looping in a picture tag, and then for everybody else fall back to an animated WebP or an animated GIF. So there's some cool stuff coming along that you can do. You can do this in Safari today. I think it'll come to Chrome eventually. But you know, there's some fun stuff we can do to, instead of GIF the format is great, but don't serve GIF, or GIF the medium is great, but don't serve GIF the format because they're so large. When I go back to what's on the web, most videos that are on web pages are MP4s, which, you know, they're just files. TS files are, whoops, I went too fast. TS files are streaming segments, and that's this, you know, the second most popular. We'll talk about streaming at the end here. But what's interesting is most web pages just have an MP4. And I think that comes down to someone said, hey, let's put a video on the website. All right, I'll just put in a video tag, paste in the MP4, and done, right? This is the baseball page for the Boston Red Sox in the States. And after every single game, there's a recap video. And this is the desktop video. It's the exact same video on mobile. I didn't quite get the screenshot at the same spot. But what's it? It's 17.8 megabytes. And that's really not that bad, right? It's a minute and 23 seconds long. It's a recap of a full baseball game. It's 1.7 megabits per second. It's big, but we could probably make it smaller. One thing you could consider doing is just lower the bit rate a little bit. And I use Cloudinary to do this. It's just a cloud-based tool. It's a great way to do it automatically, really easily. And what this did is it lowered the quality of the video to 70. It lowered the audio quality because it's just a newscaster, right? We're not looking for like stereophonic sound here. And the file became 13 megabytes. It's 20% smaller. And then I thought, well, what if you made a mobile-specific version? And what if you just resized it to 640 by 360? It goes down to 6 megabytes. So you're using about the same amount of data on your server, but you're going to be transmitting a lot less data to your customers, and they probably won't even notice a difference. It'll still look great. So you can consider having different size video for different devices. Another thing I found is this is a website where on desktop they serve 260 kilobytes of video when the page loads, but on mobile they serve 500. So why are they serving twice as much data on mobile than they are on the desktop? Well, it turns out that the tests on desktop were run with a regular device, so they download these WebM files. But on mobile, the device had a Retina screen, so they downloaded Retina versions of all of the movies. Which is kind of cool, except that they were little animations, right? And there was no real reason to have a Retina version of this video. I don't think anyone would notice the difference. And actually, you can see in the source code that they have Retina versions, and then they have regular versions. So, by default, these mobile devices are going to get a larger version of the video. But I can guarantee you that the mobile users were not able to tell a difference because it was all hidden by the CSS, right? So the videos are downloaded, but they actually hid the videos for screens with a width under 1024 pixels wide. The video never showed up on the screen. So if the video isn't going to show up on the screen, we probably shouldn't download it onto the mobile device. Again, it's only 500K, so I guess it's only €5 when I'm in Russia, but still, that's it's still money. Another thing that I've seen is inside the video tag, there's a preload equals auto. And in the browser, when you say preload equals auto, the browser will automatically download the entire video, whether or not the user presses play or not. And so how many times have you been on a website on your phone and there's a video and you're like, well, do I really want to watch it on my phone? Do I really care that much? And do I want to spend all that data? In this case, the web page decided for you to the tune of about 24 megabytes of data being served every single time this page loads. Now, there's obviously a cost to the customer for this on mobile, but there's also a cost to you, to the development and to the company serving this much data every single time the web page loads, and we'll get to that. But I would recommend, preload equals auto is great if you think like 95% of the time people will watch the video, right? If they're gonna watch the video, preload equals auto. But if there's only like a 15, 20% chance that they're gonna watch the video, it's probably not worth doing. The default setting for this in Chrome is preload equals metadata. And in Chrome, what that means is it downloads 3% of the video. Which, there's some video being downloaded, there's not a lot. In this case, on this waterfall, it's a little hard to see, but that green line is the video. And you can see there's a lot, the length is showing you that it's taking a long time to download. And when I see something like this, I sort of call it the mobile middle finger because they're downloading a whole lot of data on a mobile device. And in this case, I've got one request for video. You can see in the table it says just one request for video, but that one request is 2.7 megabytes. Now, the reason it's so big, like I said, they only download 3% of the video. But the video is 97 megabytes long. It's a 97 megabyte video on this web page. It's 2.5 minutes long. It's 1080p, which is probably a little bit large for mobile. But maybe people are going to watch this video a whole lot. So let's figure out where it is on the page. Those are the first 8 views. Here's the first 16 views as you're scrolling. There it is, way at the bottom of the page. 98% of the users aren't going to scroll that far down the page anyway to even find the video, much less play it. So in this case, even with the default of preload equals metadata, it might have been smarter to say preload equals none. It may have taken a little longer for the video to start up, but honestly, 2.7 megabytes for every single person, and most people won't even know it's there, it's probably not worth it. So when you have a preload tag, the auto is great unless if you know that they're going to play it. But if they're not going to play that video, you should avoid it. Metadata is great for smaller videos, but if it's a really, really large video, you might even want to consider preload equals none. Another really popular thing that's coming around on the internet today is background videos. This is a place where you can take your kids to play. It's like an indoor gym. And there's studies out there that show having a video in the background increases the engagement by like 80%, but that's by a marketing company that's trying to get people to use background videos, so take that with a grain of salt. But it really is a lot more engaging to have a moving picture in the background, right? This is great. So what can we do to optimize this background video? Well, I only discovered this one because most times when you have a background video, it's usually called like background.mp4. This one was called Steven. And so I was like, why did they name it Steven? And well, it turns out Steven is talking in the background. And so 5% of the video is this audio soundtrack, like, take your kids to Kidzania, it's the best place to take your kids. And if they had just stripped that out, it would have made the file 5% smaller. And of course, 5% smaller means it downloads that much faster. So if you have a silent video, whether it's a silent animated GIF as a medium or a background video, you should just strip out the audio stream because it's going to make it arrive that much faster. And honestly, there's no reason for there to be an audio stream because it's silent. Again, it's sort of hard to see here, but on mobile, that's the video being downloaded. So the animated, or that background video downloads on mobile, except for they hide it in the CSS again. So you only get this. You just get a background. You get just an image instead of the video. They actually have, so if the viewport isn't going to support the video, you should probably just not download it at all. They have a fallback JPEG that's 1 megabyte that they also don't show. Right? So in this case, it's downloading the video, a fallback image that they don't show, and they've got like a fallback image that's showing up. Again, we're talking almost 10 euros for me if I'm in Russia. But it's hidden, again, by the CSS. The fallback image is actually hidden by the CSS. So this is another background video, and if you hang out at this page long enough, you may see the background video. It starts off like this. It's 33 megabytes. It's 27 seconds long. It's 2,500 pixels wide. And it's served at 10 megabits per second. This is a giant video. And I think this is one of those cases where it works great on my machine, like the developer has this cached on their computer. They fire up this web page and that video starts right away. But for your first-time visitor, it doesn't show up unless you've got a super fast connection. It doesn't show up very quickly. So, you should resize videos so that they fit on a device. A pro tip is if you rename the video to 720p, that doesn't re-encode the video to 720p. So you can't just rename the file. You actually have to do that. But if you go and you resize this file, it's 720p, it's 4.3 megabytes. It's still a large file. It's still 40 euros if I'm in Russia. But that's not as outrageous as 33 megabytes on a web page. 33 megabytes on a web page is pretty outrageous. And then again, it does try to download on mobile, but then eventually it gives up because it never plays. So in this case, I'm emulating a mobile device, and it downloaded 17 megabytes. It didn't end up playing, but still, 17 megabytes is a lot of data. And so I alluded to this earlier, but video isn't cheap. Any country music fans out here? Anyone? No. Anyone heard of Garth Brooks before? Country singer from America. Anyway, this is his webpage, and when you load up his webpage, he's standing there and he's singing. And the title of the name of the MP4 is Notre Dame. So I don't know if he's in France or if he's just at a Notre Dame somewhere. But it may be hard to see, but in the corner there's a little video thing showing how fast it's playing because I have a thing on an extension in my Chrome. There's also a background video behind this. It's sort of black on black, so you can't really see it, but there's a background video playing. There's this video. There's a 6.5 megabyte animated GIF, the format, right? So you can see it says Notre Dame television MP4, 51 megabytes. We've got this background video, which live back stronger, which is 7 megabytes. We've got this pre-order GIF, which is 6.2 megabytes. What's interesting here is they're all being served out of Amazon S3 without a CDN. So every single time this request is made, this data is flowing out of Amazon's simple storage. It's a great product. It's really easy to use. but it isn't free. And so the first 10 terabytes out of Amazon S3 is 9 cents a gigabyte. Well, what that basically means is the first 20 videos are free, but after that, every single time this page loads, it costs Garth Brooks half of a penny just for the videos to play. And so you could imagine you get 100,000 views, it's not big money, but it's money just for a web page. So by optimizing that video, by making it smaller, if you could make that a quarter of a penny or even an eighth of a penny, you're going to save money. Further to that, there's a bug in Chrome today, whereas if you have a large video, it doesn't get cache and it just continuously re-downloads. I filed this bug. So if you go to the Garth Brooks webpage and you just leave it open for a while, that downloaded the video 5 times, so that's 2.5 cents by me just keeping that web page open. You have to be careful about these things because it could end up, that could end up costing some significant dollars. So what we've gone through so far is be careful with DPR, with Retina images, Retina video. We've seen a lot of examples where the video is hidden on mobile, but they still download the video. That's expensive for everybody. Preload equals auto can be really expensive. Having audio on silent movies, we should remove that. Don't duplicate video traffic. I've seen it, don't have it download multiple times if you can avoid that. And really it comes down to let's respect our customers' mobile data plans. So when it came to images, and images were really big, and we started getting to really, really small screens, we started talking about responsive images, serving the right size image to the device. Well, can we do the same thing with video? And in fact, we can with streaming. And so the idea behind streaming is you have all these different available streams, and you serve the appropriate one to the device that's watching the video. And the way that's done is you have a list of all of the streams in a manifest file. It's like a menu, and you deliver that to the device. The player on the device chooses a stream, starts downloading segments. So each video is cut up into segments that are like 5 to 10 seconds long, and it starts downloading those. Those get loaded into the buffer, and the video plays, right? That's what's supposed to happen. And then as the video's playing, the player can monitor the network. And if the network's fast enough, it may go to a better bit rate. And we've seen this, right? If you're watching a video and it starts off all pixelated and crummy looking for the first few seconds, and then about 4 or 5 seconds it snaps into a beautiful looking video, it started at a really low bit rate and then went to the optimal bit rate. So why does it start at a low bit rate? A low bit rate is going to download faster. It means the video is going to start playing faster. It sort of seems logical. This is what a manifest file looks like. This is from a TED Talk. And these are the video files. These are video tracks in the iframes. And then there's a whole section for audio tracks. And in the case of a TED Talk, they have subtitles in about 14 different languages. And so that's why this is so big. But let's just talk about video because we're here to talk about video. What you can see is for each stream that's available, there's 2 lines. The first line lists the bandwidth, the program ID, the codec being used, the resolution, right? And then the second line is a list of all the files that will be downloaded. So the way the manifest file decides what video to play is it always chooses the first one on the list first. It has to start somewhere, so it chooses the first bandwidth on, it has to start somewhere, so it chooses the first one on the list. And I actually found this video yesterday. It's in Argentina. If you want to get a driver's permit, you have to go to this web page, and it streams a video. And the first video bandwidth, it's really hard to see because there are no commas or periods. I guess you use periods because we're in Europe. Sorry, I'm going back to my Americanisms. But the first bandwidth here that's being served is 37 megabits per second. That's not going to play anywhere, right? That's huge. The first segment so it's going to start off, what happens when you start streaming at 37 megabits per second? So it picks this high bitrate stream, It's trying to download what's going on, and it's taking forever. Can you imagine trying to download video that plays at 37 megabits per second on your mobile phone? Like, it's just going to take forever. And the video doesn't play. So then the player chooses a lower bit rate, and it starts downloading the lower bit rate. The buffer fills up quickly, and the video plays. But we just added an extra step here. And that's going to slow down, that's going to slow the startup time, right? And we all know that if it takes a long time for the video to start up, we lose customers. So we're starting at 37 megabits per second. And when I load that up in Chrome DevTools, it basically, that's the manifest file. The second file is the first segment. You can see it's 1080p 00000.ts. And it downloads 1.2 megabytes before it switches. So it's like downloading a 1.2 megabytes and then throws it away and then starts downloading at the lower bit rate. So, you know, 12 euros if I'm in Russia, right? But it's mostly, more importantly, it's the delay of downloading 1.2 megabytes of garbage before you actually even start downloading the video to start playing it. And that's part of what leads to, this is a different slide, that's what's leading to people not sitting there and getting the video to start, right? They give up because it's taking so long. So what most websites do is they start with the lowest stream, right? So if you start streaming with that lowest stream, the video will appear fast. It may look really bad, but it got there, right? So you're trading off, right, how quickly it gets there. And then after a few seconds, it pops into a nice high resolution. What we just saw on the website that starts at 37 megabytes, it starts at a really high bit rate. It doesn't play. It goes to the lowest bit rate and then eventually bounces up. But we added that 4 or 5 seconds of added delay to get the video to start. Interestingly, Amazon does this. I call it the Goldilocks approach. They pick one right in the middle. It takes a few extra seconds for the video to start, but it looks beautiful from time zero. And if you think about Amazon, all of their TV shows they're all TV shows. They're not short play. They know people will hang out for a little bit longer. And if you ever watch like a Prime original, like movies always start with a black screen, and then Prime originals always start with a colorful screen, and it's always sharp from the beginning. So they're trying to differentiate themselves. It always looks beautiful from the very start. So you can see here, if you start with the lowest bit rate, the video starts playing at 11 seconds. If you start at the highest bit rate, the video starts at 17 seconds. And I'm running out of time. I'm about to get kicked off the stage. So I'm going to skip streaming, a little bit more on streaming here. And third parties, no initial video download, but expect a lot of JavaScript. And then I didn't get to Facebook. I'm sorry. But we can chat afterwards. It all comes down to respect your customers' data plans, right? Let's make our videos small. Let's optimize them for fast delivery, fast startup, so they don't stall, and get it there for customers to see it. And so with that, thank you very much. I appreciate it.